Okay, hello, assalamualaikum. So in this video, I'm gonna explain about the experiment of the gas absorption, which is pre-lab 2, the effect of inlet gas composition and CO2 absorption. So the first one is theory. So as we know, the gas absorption the gas absorption equipment is designed to operate in industry as the gas mixture are dissolved into the liquid at the interface. So this happens since the gas is more soluble than the liquid. Plus it occur when the gas and the liquid at the interface has concentration gradient. The gas feed will enter into the column at the bottom through the stream called gas in stream, while the liquid solvent will enter at the top of the column through stream called liquid in stream. In the column, it has much of packing that react as catalyst. So these catalysts help the liquid and the gas to have more contact area while dissolving process. So at the end of the process, the sample or solutes will be collected at the bottom stream of the column called extract stream. Meanwhile, the gas that did not dissolve will leave from the column at the top of the stream called raffinate stream. So the objective of this experiment is the first one to operate the gas absorption unit to determine the effect of the water flow and inlet gas composition on the efficiency of CO2 absorption. We also to determine the concentration of CO2, and the last one is to perform the formulas for the calculation. So this is what we call flow diagram. So there are some description and the assembly that I will explain in this PFT. So the first one is receiving vessels. So this B1 and B2 is receiving vessels. That is 50-liter cylindrical vessels that equipped with charge port and ventings. So the second part is K1. This K1 is what we call absorption column. This is the main unit that we will use in the experiment. So this column is actually packed with the glass rest cheek rings. So this rest cheek ring is react as the catalyst that, as I said before, this catalyst is performed to increase the contact area of the gas and the liquid. So the last part is this is what we call centrifugal pump. So this centrifugal pump will what we call is a flow. We increase the flow rates or the velocities of the feed into the distillation column, into the gas absorption column. So before we run the experiment, we should perform the operating procedures that includes general startup procedures, general shutdown procedures, CO2 analyzer procedures, liquid sampling procedures, and analysis of dissolved CO2 in water. So the first operating procedures is general startup procedures. So the first one, we have to ensure all the valves are closed except the ventilation valve, which is HV13. This valve is we have to make sure that it is fully open. So after that, we drain any stagnant above the sampling valve of HV3. This valve, we can drain any stagnant liquid through this valve. So after that, we open the valve on the compressed air HV01 and valve of CO2 supply, which is HV02. After that, we set the pressure air supply is 0.2 megapascal and pressure of CO2 supply is 2.0 megapascal by turning the regulator knob clockwise. After that, we can turn on the main switch. So after we start up and we perform the general startup procedures and we run the experiment, we have to perform the general shutdown procedures. That is, the first one is we have to turn off the pump 1, which is P1, and after we turn off the pump, we have to close valve water supply, valve water supply and valve HV 01, HV02 and HV11. HV11. So after we close these three valves, we have to drain all the liquid from K1 by opening the valve HV3. This step is to drain all the liquid from K1. So after we drain all the liquid through HV03, we drain all the liquids from receiving vessel, which is B1 and B2, by opening HV07, by opening the valve HV07, HV08 and HV08. These two valves, when we open it, we have to drain all the liquid from these receiving vessels. So after that, we close the valve HV03, HV07, HV08, HV04 and HV10. So after we close this valve, the next step is we close the valve of HV14, HV12, HV15, HV16, and the last one is HV17. After that, we have to make sure only HV13, we have to ensure that HV13 is fully open. Then, after we perform above steps, we can turn off the main switch. So the next step is to perform the CO2 analyzer procedure. So the first one is we have to switch on the control panel and let the system on for about 15 minutes. to stabilize the system and to make sure the CO2 analyzer is warming up. And then after that, check the control panel, which is QT401 and QT402, achieve the constant value. Next, we have to push the reset button, which is at the QT401 and QT402 on the junction box for about 2 seconds. So after that, we turn on the air compressor at 2 bar and let the air flow into the systems. Next, we have to let the system running about 5 minutes to ventilate the remaining CO2 in the analyzer. Then, once the reading of CO2 shows the zero value at the indicator display, the experiment is ready to run. So the next step is the liquid sampling procedures. Actually, the samples can be taken from liquid entering and exiting the absorption column. So there are two valves where we can collect the sample, which is HV08 for inlet liquid to absorption column and HV03 for outlet liquid from absorption column. So these are the steps that we have to perform to collect the liquid sample. The first one is drain any stagnant liquid above the sampling valve. So next step is place a vial below the sampling valve. Then open the sampling valve and collect about 150 ml of sample. Then we close the sampling valve. So the last one of operating procedures is analysis of dissolved CO2 in water. Actually, water used for absorption should be deionized because of the presence of dissolved salts could affect the analysis method as described below. So chemicals needed is so there are 3 chemicals needed. The first one is deionized and CO2 free water. Number 2, phenolphthalein indicator, which is what we call AR grade. And the last one is 1.0 liter of standard 0.05 m sodium hydroxide solution. So after we perform the general startup procedures, we can run the experiment. So these are the experiment procedures, I'm sorry. So the first one is perform the general startup procedures and then open the valve HV12, HV13, HV14, HV15 and HV17. Then fill feed tank B1 through the charge port with 30 liter of water by opening valve HV04, HV07 and HV17. Next step, open and adjust valve HV01, which is air supply, to give a flow rate of 30 liter per minute air into the column K1. Then open the valve HV10 fully and while the valve HV19 slightly. Switch on pump 1. Observe the flow of water from vessel B1 through pump 1. Then slowly open and adjust valve HV11 to give a water flow rate of around 1.5 liter per minute. Then observe the water flow rate indicate at FT03, which is what we call the flow rate indicator at the control panel. Next, allow the water to enter the top of column K1, flow down the column and overflow back into vessel B1. Then collect the initial liquid, which is 100 milliliter, from valve HV03. Next, open and adjust valve HV02 to give flow rate of 3 liter per minute of CO2 supply into column. Then we have to let the process run about 5 minutes to allow the column stabilize first. Next, start the collection of the liquid samples, which is 100 milliliter, from outlet of absorption column from valve HV03 at every 5 minutes. Then, but at the same time, record the outlet composition of CO2 showed by QT401 at control panel. Then continue to collect the samples, the liquid samples, and record the outlet Z composition of CO2 at every 5 minutes intervals until there is no more changes in CO2 composition over time. Analyze the collected samples to determine the composition of dissolved CO2. So that, and next, always, but then we have to always monitor and maintain the air, CO2 and water flow rates by adjusting the related valve, which is HV01, HV02, and HV11. After we run the experiment procedures, so that we can perform the general shutdown procedures. So there are some missing data that we will get it. So the first one is the concentration of CO2. The next one is the volume that we use. And the last one is the moles of CO2. So how we can obtain the missing data? So the first one is, for the moles of CO2, we get the volume and divide it by 24 decimeter cube. But the volume must be in decimeter cube also. So for the volume use, we can use final volume minus by the initial volume. So the last one, for the concentration of CO2, which is in molar, we can, which is molarity, we can use moles of CO2 that we get before divided by the volume used in the decimeter cube. So what is the expected result from this experiment? So the first one, we can determine the concentration of CO2 for each time taken. Next one, we also can perform the calculation based on some formula that being used. So the last one is, we can determine the effect of water flow rate and inlet gas composition on the efficiency of CO2 absorption. So that's all from me. Thank you.